Watch. So, do you know how to get to my website?
Yeah.
Okay. Under 1010, we're in chapter 7, right? So you just click on chapter 7, the very first link in every chapter. Here are the lecture notes. So if you ever missed class or something and didn't want to get behind, download the notes, print them off, and then watch the video. So if you click on view or download if you want to do a PDF, there's the link for 1.6. And when I'm done today, like this is recording right now, there'll be a link right here by the end of the day today. If you wanted to watch today's lecture again, you just click on that. It opens up a video, and there you go. Okay. Sad we're almost halfway through, and we're still figuring that out. Very sad. Okay. All right. So again, 20-minute lecture found right there. When we're talking about exponentials, there's a base and there's an exponent. We're going to modify that just slightly today. And it also goes through and it talks about how there are, what happens if you have a positive exponent or a negative exponent and different things like that. It talks about the properties of exponents that we see right here, okay, like power to a power. Like if you were to have like x squared to the third, you multiply them, that's x to the sixth, that sort of thing. So we went through and did those. So again, get done with 1.6. It has to be done by tomorrow. If you already did it, then you're in much better shape for understanding today's material. So let's go ahead and start that. So this section is on radical expressions and functions. So there are a couple starter questions here. And the first question, well, actually the first two questions, they seem like they're kind of related, and they are, but you've got to think carefully about these. It says, what is the square root of 1? What's the square root of 1? It is 1. Okay? The next question is, what number do you square to get 4? What did you say, Sarah? 2 or negative 2. That would be plus or minus 2. So you'll notice there's a difference in the way those things were asked. This one asked for the square root, and when we write the square root, we're talking about the principal square root. We're talking about the positive one. When we say, hey, what numbers could you square to produce this particular number? Yeah, even though you could take the square root of 4 and get 2, you have to remember that when you square something, you lose the sign. So if you started with negative 2 and squared it, you'd get positive 4, just like if you started with positive 2 and squared that, you'd get positive 4. Okay? So you've got to be careful with those. And knowing the stuff that is in 1.6 is really helpful for this next one. So again, one last time, make sure you get that video watched, fill out the notes, and get the section done. So on this first example, we've got 3 squared. Now everybody knows what the answer is to that, but I want to look at this in a little bit different way. When we do 3 squared, what it means is 3 times 3. Squaring takes one factor, it takes the base, and it makes it look like 2 of them. So we do 3 times 3, and that's why the answer is 9. So when we square something, it changes one factor into 2 factors. And like we've mentioned before, a lot of the stuff that we do in math is we learn how to do something, and then we learn how to undo it. So if we know how to square something, or cube something, or raise it to the 4th power, we ought to know how to undo that process. Okay? So radicals undo squaring or cubing or different things like that. Okay? So we need to talk about this symbol right here. This is called a radical sign. Everybody knows that. You've probably seen that before. Does anybody know what the name is that we give this little number that goes in the little crook of the radical sign? Fabulous. It's called an index. Okay? It's called an index. And does anybody know what we call what's underneath the radical? There we go. Radicand. Okay? So this is the radical sign. We tell whether or not it's a square root, a cube root, a 4th root, whatever root it happens to be by looking at the index. What's the little number that's in that little crook there? And whatever's underneath there, we call that the radicand. So on this problem right here, this is a square root. The index would be 2. We normally don't write it just because that's the most common one. It's just understood to be a 2 is the index, so it's a square root. The radicand is 9, and here's how this works. When we square, it takes one factor and it makes it look like 2. Well, when we take the square root, it does the exact opposite. It takes 2 factors and it makes it look like 1. So when I simplify the square root of 9, here's how we'd simplify it. Now, I know you know the answer is 3, but let's talk about why. We factor this, and then because we're looking for the square roots, we're looking for pairs of factors. So I've got a pair of 3s. I'm going to take that. I'm going to move those and make it look like there's just one on the outside. Now, when I take things out, there's always a 1 left. Because remember, this is a multiplication problem. So technically, this is 3 times the square root of 1. Square root of 1 is 1. So the easiest way to write this is 3. Yeah?
Would you have a plus or minus?
No, because whenever you're writing a square root, it's talking about the principal square root. It's the positive one. Okay? It's when you use that symbol, it's always talking about the principal root. When you put a square root in a problem, then you have to account for the plus or minus. If you're putting it in there, you've got to have the plus or minus. Okay? So when we take a square root, it takes a group of 2 factors and turns them into 1 factor. Let me make this nice and symmetric there. So we're going to do some problems that I realize you know what the answer is to each one of these, but the way you'd want to think of it, at least visually, would be this. There's a pair of 5s. There's a 5 on the outside. A 1 is left underneath, but the square root of 1 is 1, so we don't have to write that. This is a pair of 7s, so the answer is 7. Again, we could even do that on this problem. There's a pair of 1s. Okay, and what do we have here? The quick way is to write that as a pair of 9s, or what if you did this? 3 goes in there 27 times. 3 goes into 27 9 times, which is 3 times 3. Pair of 3s. Another pair of 3s. How many 3s would be on the outside? 2, so that's a 9. Okay, now let me stop right there. Are there any questions? Sure? Okay, so on 144, you could do 2s and 3s and all that sort of stuff, but the easiest way to think of that is 12 times 12, pair of 12s. The answer is a 12 on that one. Good? Okay, now, if you keep in mind that that's what square roots do, they take a pair of factors, that's why we have to know how to factor in order to do this, and turns it into 1 factor on the outside, then we can do problems like this. 18 does not have a nice square root. But if we factor this, this is 3 times 2. It's 9 times 2, right? Pair of 3s, I can write that on the outside. What's stuck underneath? The 2. Now, why can't we take the 2 out? Because there's only one of them, right? Okay? You don't have something about they got to be married or anything like that. Okay. All right, good. Okay, so we got 3 radical 2. On this one right here. Oh, no.
You can say they have to be twins to come out.
Twins, okay, I feel a little more comfortable with that. Okay? As the numbers get bigger and you have to factor more, if you need to do a factor tree, go ahead and do a factor tree. Like if it's 48, 2 and 24, 2 and 12, 2 and 6, which is 2 and 3. So if we write this all factored, it's 2 times 2 times 2 times 2 times 3. It's 16 times 3. Yeah.
So if we didn't know that like 48 would go into 2 and 24, could we do 6 and 8?
Sure. It'll work the same way. Okay. So if you do 6 and 8, so in fact, let me do this. Everybody convinced we've got 4 2s and a 3? Okay. So the question is, what if you didn't think 2 and 24? What if you thought 6 and 8? 6 is 2 and 3, 8 is 2 and 4, and that's 2 and 2. And remember, you grab the bottom of every one of these branches. How many 2s? 4 and 1 3. So either way, if we prime factorize, we get to here. Pair of 2s, pair of 2s. How many 2s on the outside? 2. That's a 4. And what's stuck underneath?
3.
A 3. And again, why is it stuck underneath? Okay, they got to come in pairs. There's not another one. It doesn't have a twin. Okay? Now, if you can do this stuff in your head, that's great. Or if you thought square root of 9 times the square root of 5, since we're talking, is that all right? Either way, pair of 3s, 1 on the outside, 5 stuck on the inside. And this is where it gets more interesting. Everybody watch, please. You have to watch these. This is going to show up on the test. Okay, these are not numbers. These are variables. So you have no idea what number they are or what sign they are. But when you take the square root, you have to make sure that the answer is positive. So let's take a look at this. If I were to write this in factored form, it's x times x. There's a pair of x's, so I have an x on the outside. Technically a 1 underneath, but we don't have to write the square root of 1 or anything like that. Everybody okay there? Now, do we know whether x is positive or negative? We don't. So, and you only have to do this if you have an even root, and this has an odd exponent. Right now this is a 1. If it's an even root and an odd exponent, this could be a negative number. So how do we guarantee it's positive? Put absolute value bars on it. Now, this is a technicality that comes up fairly often. You've got to be aware of it. I'm sure it will be in Math Excel. So let's take a look at this problem right here. And again, we're looking for pairs of factors. If you have to write this one out this way, please do. Make sure you get it right. It's not that hard to write it out. Square root, we're looking for pairs of factors. Pair of y's, another pair of y's. How many y's on the outside? 2. So I have a y squared. The 2 is stuck underneath. Now my question for you is, outside is a y squared. I don't know whether this is a positive or negative number for y. Do I need absolute value on this? Okay, I hear a bunch of no's. Somebody that said no, tell me why I don't need it. Chrissy.
Because since it's squared, even if it's negative, it'll become a positive.
Very good. We know this is positive, and regardless of whether the y was positive or negative, once you square it, it's going to end up being positive. So do we have a principal square root here? We do. Now, would it be the end of the world if you put absolute value on there? It wouldn't, but you don't need it, and you probably shouldn't put it, because that kind of shows a lack of confidence in you knowing what you know how to do, okay? All right, any questions there? Okay, that's how we handle square roots. Take pairs of factors, turn them into one factor on the outside. If we're talking cube roots, well, that's a 3, so we're looking for groups of how many? Groups of 3. It's going to turn a group of 3 factors into 1. In fact, on this problem right here, cube root, 2 times 2 times 2. There's a pair of 3 2's, so there's 1 on the outside. And isn't the cube root of 8, isn't it 2? Okay, and there's factoring that shows why it's a 2. Okay, are there any questions? So why does the cube root change a group of 3 factors into 1? Because it's the inverse of cubing, right? Cubing takes 1 factor, makes it look like 3. Cube roots do the exact opposite. Okay. How are we doing? Okay, take a look at these next examples. Okay, I want to point this out. Everybody makes this mistake sooner or later, so please make it happen as infrequently as possible. Here's what happens. People go through and do this problem and they think, okay, 3, 3, 3, let's see, pair, so that's going to be 3 square root 3. What's wrong with that? Okay, everybody sees a radical, and because square roots are so common and we use them so much, people forget when they're using a cube root, they have to do it according to the rules for cube roots and write the answer with a cube root. So this will happen. 3 3's, right? Done? Okay. What's that? Triplets. Okay, I'll take triplets. 4 times 4 times 4, or you have to write it like that. Group of 3, answer's 4. Sorry. Did I get this right? Yeah, here we go. Group of 3, that would be 2 2's, which would be a 4 also. Okay? Yeah.
The outside numbers, do you multiply them or do you add them?
You multiply them. Okay. Because they're factors. Factors are in multiplication. What about this one?
9.
We did this one up above. You could do 9 and 9, which would break down to 3 and 3. So you've got 4 3's. Groups of how many? Groups of 3 or triplets. Grab those. 3 here, and then again, this is the common mistake. Look at the way I wrote the answer here. If this was a problem on a test, I can see you know what you're doing, but you wrote down the wrong answer. If this was worth a couple points, you would lose one of them because you haven't written the answer the right way. You've got to remember that if it's a cube root to start with, it's probably going to be a cube root to finish with. So that's what we've got there. 24, we did this one just a second ago. 2 times 2 times 2 times 3. Group of 3. So it's going to be 2. Again, don't forget the index. Cube root of 3, not square root of 3. Okay, and then here's where they get a little bit interesting. I like these. Groups of how many? Groups of 3. Okay, there's a group of 3, so I can have a 2 on the outside, right? How many groups of 3 x's do I have? I've got one group of 3. How many group of 3 y's do I have? I have 1. Now, I'm going to write, again, cube root, write the index. What number was left? There was a 2 left. How many x's were left once I took out a group of 3? One of them, so that's just an x to the first. And how many y's were left? 2 of them, so that's going to be y squared. Take a good look at that. You have quite a few problems, and I can guarantee you're going to see several problems on the assignment and on the test that look like this. Yeah?
Wouldn't you put the x and y on the outside opposite values?
Glad you asked that question. Take a good look. Do we need to put the x and y on the outside in absolute value? The answer to that is, Sarah? The answer is no. You only have to do that if it's an even root. If it's an odd root, it can be negative or positive. So like the cube root of -8 is -2, because there are 3 negatives there. Okay? So you only have to do the absolute value if it's an even root. So square root of 4th root of 6th root or something like that. Okay? All right. So the cool part about thinking about this that way is if we change to different roots, like 4th root, 5th root, I think we've got, what do we have here, 17th root or something like that? Okay. 71st root? Okay. How many, groups of how many? Groups of 4. Okay. One group of 4 2's, so the answer there is 2. It's an even root, we better guarantee it's positive. We wrote down the number positive 2, so we're in good shape there. This is an interesting problem. 4th root of 5 to the 4th. That tells us how many 5's we've got. How many? We've got 4. We're looking for a group of 4, so we got an answer of 5. Not only that, what does the 4th root have to do with raising something to the 4th power? What does the 4th root have to do with raising something to the 4th power? What does the square root have to do with squaring? It's the opposite, or they're inverses, right? Okay? So taking a 4th root is the inverse of raising something to the 4th power. So they should undo each other. Okay? Groups of 5. The A is easy, right? 32. 2 times 16, which is 2 times 8, which is 2 times 2 times 2. 5 2's. So this is a 2A. Take a look at the next one. We're looking for groups of 8, right? I've got 8 10's, and I've got 8 x's. Do I need anything else, Parker?
Wouldn't the answer for the last one be like in absolute value?
Good question. On this one, would it be an absolute value?
No.
No, because it's an odd root. If it's a 3rd root, 5th root, 7th root, anything like that, we don't need the absolute value. What about this one?
Yes.
That one we do. Can somebody tell me why? Because it's an even root, and this isn't squared or raised to the 4th power or something like that. This could be positive or it could be negative, so we're going to put that in absolute value. What if you did this? Put the whole thing in absolute value. Would that work?
Yep.
It would work. It's a little bit overkill. The 10's already positive. It doesn't need the absolute value to make it positive, so we'd be okay there. And then the last one, it would be 9, because we're looking for groups of 71, and believe it or not, there are 71 9's there. Yeah. What do you mean? No, this is a 71st root. So this is 9 times 9 times 9, 71 times. So we'd circle one group of 71 nines. Good? Okay. Happens all the time. I was at the grocery store the other day. That happened to me. I'm kidding. Seriously, you never have to do roots at the grocery store. You only have to factor polynomials at the grocery store. Okay, so go ahead and flip the page over. And again, this just kind of summarizes what we've learned. Okay, there's a difference between these two questions. What's the square root of a number? Okay, versus if we have that radical sign there. So what number do I square to get 25? Plus or minus 5. It's that symbol that tells us it's the principal square root. So if they don't use the symbol,
Bless you.
could be plus or minus. If they do use the symbol, it's got to be the principal square root. Okay? Or if they said it a different way, what number do you square to get 25 or something like that? Okay? So that radical is always asking for the principal square root. That makes it positive for an even root. Okay? So even roots have to be positive. Odd roots can work out to be positive or negative depending on the sign of the radicand. So if I have the square root of 4, that's got to be a 2. If I have the cube root of 8, that's got to be a 2. If I have the cube root of negative 8, it's like we talked about earlier, there's a group of 3 negative 2's. So the answer is negative 2. Does that make sense? Sure there are no questions about that? If I do the square root of 9x, 3 on the outside, x on the outside, it's an even root. Better put the absolute value bars on there. Okay, watch the next one, please. Again, we're just kind of reviewing the details. Even root. Do I need to worry about absolute value on the answer? It's an even root. I better be concerned with that. It's an even root. If it were a third root, a fifth root, a seventh root, I wouldn't have to worry, but it's an even root. So I get a 25, x to the third, y to the second. Now, take a look at that. Did I get that right? I've been known to make mistakes in the afternoon, especially on Monday. It is Monday, isn't it?
Yes.
Is that right?
No.
Okay, do I have at least the right numbers and variables and all that sort of stuff?
Wait a second.
Do I have the right numbers, variables, exponents, all that sort of stuff?
Some missing stuff.
Thank you very much. Okay. Do I need to worry about anything here? The answer there is yes, I do need to be concerned, again, because it's an even root. Am I worried about the 5? No, it's positive 5. Am I worried about x cubed? Yes. Because if I put a positive in there, it's positive, but what if I put a negative in there? Negative cubed would be negative times a negative times a negative. 3 negatives would make that negative. We want to guarantee that this is positive, so we put that in absolute value. Do I need to have the y squared also in that absolute value? No, because it's going to be positive. That would be the correct, most efficient way to write that. Do I need to be worried about the next one as far as absolute value or anything? Tyler? Why not? Okay, the index is odd. That's the important part, okay? So, cube root, looking for groups of 3. 3 on the outside from the 27. X to the second. Y to the... Well, wait just a second. I only have one group of 3, right? So I can put a y on the outside, and then one of those has to be stuck underneath there. Now take a good look at that. Christopher, what's wrong? We're missing the index. This was a cube root to start with. We better indicate that that's a cube root to finish off unless something really weird happens. And then take a look at the last one. A better way to say it is not that they cancel, what do they do to each other? Undo each other. This one takes that x minus 4, gives you 5 of them. This takes those 5 of them and turns it back into one of them. So it's x minus 4. My question for you is it positive or is it negative? How many say negative? How many say positive? Okay, we got a bunch of no votes. Thank you very much. It is negative, and here's why. Even though this isn't included, if you have a negative odd root, the answer's always going to be negative, and here's why. If I took 5 negatives, whoops, let me make that look like a negative, and then x minus 4 raised to the 5th, isn't that 5 negatives right there? And doesn't that multiply to be a negative? So couldn't I take those 5, put it on the outside, take those 5, put it on the outside? Wouldn't that work? Is this how you'd write the answer? Probably not. Negative x plus 4 is probably how you'd write it. Okay. Any questions? Okay. Another key point when working with radicals, you can't take the even root of a negative number. We've talked about this several times already this year. Why can't you find the square root of negative 4? Yeah.
Because when you try to factor it, you'll have to get negative 2, 2. That's never work.
Negative 2 or 2, or 2 and negative 2. They have to be exactly the same factor. Now, in Chapter 9, we'll learn about imaginary numbers, and we'll work with those. Or let's see, I think we would do that at the end of this chapter, actually. Okay, so we'll get there. Okay, but you can't make a pair of the same numbers if it's negative. So you got to find other way to do that. Okay, and here's how I say this: radicals play well with fractions. I realize fractions are not your favorite, but radicals actually are pretty nice when we're working with, or fractions are pretty nice when we're working with fractions, and it's because of this. Radicals have this nice property because they're kind of an exponent, okay? And we'll talk about that for sure next time. Where we can take this and we can break this into the square root of the top over the square root of the bottom. Square root of the top is 1, square root of the bottom is 3, answer there's 1/3. So even though it was a fraction to begin with, and even though it's a fraction in the end, computing the square roots is actually pretty easy. So this is like the square root of 25 over the square root of 49. 5/9. There you go. Hey, I'm just seeing if you're still awake.
Sure.
Positive or negative? Negative. Cube root of 27? 3. Cube root of 8? 2. Ouch. What is it? Okay, negative. 5th root of 1 is 1. 5th root of 100,000. 5 zeros, so that would be 5 tens. So this is negative 1/10. Ugly if you had to think about that in terms of decimals, but with fractions, it's pretty darn easy. Questions? Okay. Now, again, this is the reason why we made those distinctions about the difference between a radical asking for a square root and just words. For numbers 9 and 10, and again, you have similar problems like this on your Math Excel homework. For each number, find all of its square roots. In other words, what numbers can you square to make 64? 8 and negative 8.
Question.
Yeah,
Can we just do that plus or minus 8?
sure. 81
Plus or minus 9.
plus and minus 9. For 35, for each function, find the specific value if it exists. So f of 3, plug in a 3. 5 times 3 minus 10, square root of 5. I mean, it's literally that simple. Let's do f of 1. Square root of 5 times 1 minus 10, that's the square root of negative 5. Nope. We could say does not exist. Okay? Or we could say, better yet, not real number. Okay? Any one of those would be okay. Yep.
So for, say, the f of 2, that would be 0. So just square root of 0 is 0.
Zach, is the square root of 0 0? Square root of 0 is? Well, let's see. If these rules that we figured out actually work, it takes a pair of factors and turns it into 1, right? Is 0 times 0 still 0? Do I have a pair of zeros? Yep, so a 0 on the outside. Technically, what would be left underneath? a 1, and what's 0 times 1? 0. Square root of 0 is 0, okay? The only thing you can't take the square root of, an even root of, is a negative. You can still take the square root of 0, okay? Good question. Good clarification. Anything else? Okay, let's take a look at the last couple then. Hopefully pretty easy. Maybe you don't have to write down any work at this point. What's the number on the outside? What's the variable? Do we need absolute value? Yes, we do, around the t. We have to guarantee that that's positive because it's an even root. Haven't done one like this. But does that look familiar, especially given the fact that we've already done chapter 5, which had all the factoring rules in it? This has a name. What's it called? It's a perfect trinomial square. Perfect square of x and negative 2. Pair of x minus 2's. So there's an x minus 2 on the outside. No one's going to say anything? Absolute value. Thank you very much. Watch, please. This does need absolute value. Does it go around here, or does it go around the whole thing? Okay, this was a factor, so we put it around the whole thing. So it should be in absolute value. Okay, that's what we wanted to guarantee was positive, is that factor right there. Okay, let's do the one right below it. Easy? 7b. Do we need absolute value? Yes, we do, because it's an even root.
Just round the b, not the 7.
We could put it around the 7, but we know the 7's already positive. It's a little redundant or overkill.
So we only need it around both things if it's adding and minusing it.
Mm-hmm. Yeah, because this... Holy cow. I'm afraid that's going to stick. That's the scary part. Okay.
I hope people watch these videos.
Yeah, let's hope so. Okay, take a look at this one. Pretty easy, right? These just undo each other. The answer is y. Does it need absolute value? Yes, it does, because it's an even root. It's an 8th root. Careful on this one. Cube root of a negative. Can we do that?
Yes.
Yes, cube root, because it's an odd root. Okay, the answer to this part is negative 10. But there's a negative out front. So in the end, what's the simplified answer? Positive 10. And this is a number that comes up occasionally. If you had to guess, 625 is 5 times 5 times 5 times 5. It's 5 to the 4th. It's 25 times 25. Okay? So the answer here would be 5 with a negative out front. Is that a problem even though this is an even root? The answer is no, it's not. Can somebody tell me why it's not a problem to have a negative answer to this particular problem? Yeah.
Because the negative was outside of
The negative was outside. It wasn't the radical that turned out to be negative. It was the sign out front that made it negative. Okay? And then it says on this example right here, assume no radicans were formed by raising negative quantities to even powers. That's just a fancy way of saying everything underneath there was positive to begin with. So this would be 4x. Do I need absolute value? No, because they told us everything was positive to begin with. And on this problem right here, this would be 5t. Again, you wouldn't need that. Now, I'm not quite sure why they have you practice that, because most of the time we don't know whether the variables were positive or negative to begin with. Maybe they're just trying to make life easy. Set your mind at ease for a second. Take a look at the last problem. These are ones that are going to come up again and again and again. This comes up in my calculus class. It comes up in my trig class. Here it's saying find the domain of each function described. Do you have to be concerned with even roots? The domain of even roots. Yeah, you can't take an even root of a negative. So whatever this is, it's got to be, we say it's non-negative. That means it's greater than or equal to 0. So that means when we subtract 8, here's our domain. You can only plug in numbers that are bigger than or equal to 8. So if we wrote it in set builder notation, it would look like this. If we wrote it in an interval notation, we'd say, hey, the answers start at -8, and they go all the way to positive infinity, square or round around the negative 8? Square. Okay. Any questions there? Okay, take a look at the last one, please. It's a cube root. Do we have to be careful taking the cube of positive or negative numbers? No, they all work out. Okay, there are no domain issues with odd roots. So if you come across a cube root, a fifth root, a seventh root, a 71st root, you can plug anything you want in there. Okay? So no domain issues here, so we'd say all reals, or we could say negative infinity to infinity. Those are infinities, those aren't 8s, promise. Okay, any questions? Okay. Has anybody seen Ari today?